So welcome to Microprocessor Lab. So in this session, we are going to learn how to write an assembly language program to perform the division of two unsigned numbers using 8086. The division operations can be performed on unsigned number and the signed numbers. So let us concentrate on the division of two unsigned numbers. The mnemonics used to perform the division of two unsigned number is DIV, register bar memory. Here are two type of divisions that can be performed. One is the divide a word by a byte, divide a double word by a word. So the first one is a 16 by 8-bit division. The second one is a 32 by 16-bit division. So in case of a 16 by 8-bit division, so the numerator is the dividend is an AX, the divisor is a byte in the register or from the location. So before the execution of DIV, the AX will have a dividend. After the execution, the quotient will be in AL, the remainder will be in AH. Let us take an example. Here we have two operand, data 1 and data 2. Data 1 is 7F and data 2 is 0EH. So now we are going to execute div BL. So this BL, the BL is 0E and AX is 007F. And here we are going to perform a 16 by 8-bit division. But here the data is what byte. So in case of byte, what the processor will do, it will take the value from AH. 8-bit data will be converted to 16-bit. But we know that the number is a positive number. So the MSB bit is equal to 1. So in that case, AH is equal to 00. So in the program, we have to load AH with 00. So now the AX is 007F and BL is 0E. So this is the calculation part. So we have taken 7F, we are going to divide with 0E. So the quotient here is 9, the remainder is 1. So in case of a 32 by 16-bit division, which is nothing but divide a double word by a word, the dividend numerator is in DX concatenating with AX. The divisor is a word in a register or from the location. So before the division, so we have to focus on dx concatenating with ax. After the division, so the quotient will be in ax, the remainder is in dx. Here also both the datas are 16-bit, but we are going to do what a 32 by 16-bit division. So we have to consider this dx. So in this case, the dx will be loaded with 00. So dx colon ax will have a 32-bit number, which is nothing but the double word. We are going to divide with a 16-bit data from the register or from the location. The value will be in, the quotient is in ax, the remainder is in dx. So this is the calculation part. Here we have taken two numbers, 2244, the second number as D6. So using the long division method, we are getting the quotient as well as the remainder. So we know that dx we have to load with 00. We know the number is a positive number. How MSB bit is equal to 0. Then AX is nothing but 2244. That is the example we have taken. And BX is 00D6. After the execution, in AX will have 0028. In DX will have 00D4. And this is the program for 16 by 8-bit division. So when you start writing the program, we have to include the assembler directive. And we are telling the assembler the code segment is less than or equal to 64 KB and data segment is less than or equal to 64 KB. So for that, we have to go with dot model small. Then we have to initialize the data by writing the data segment data endes. Here we have taken the variable num1 and num2, and this is for the result, for the quotient and the remainder. So we know that the number here is byte. So we have to go with define byte followed by number, and num2 define byte followed by the number. For the here the result is the quotient and the remainder. So we have to use two variable. For that we are using a result as the output variable, defining as a byte. 2 is duplicating a copy of it. 2 copy of result will be duplicated. Data end is a code. We have to start with the code segment, and we have to tell the assembler assume CS is nothing but code and DS is nothing but data. So CS is the code segment and DS is the data segment. Afterwards, we have to take the address of this data. We have to assign to DX. So through AX, we are assigning the address of data to DS. Once this is done, we have to take the number num1, load it to AL, and num2 we have to load it to BL, and here we have to load AH with 00. So we have to go with move AH comma 00. So once this is done, we have to go with the division. It's an unsigned division. So we know the mnemonics for unsigned division, which is nothing but div followed by register. So we are getting the result, which is nothing but the quotient and the remainder. We know the quotient is in AL, the remainder is in AH. So from AL, the value will be transferred to the result. From AH, the value will be transferred to result plus 1. Once this is done, we have to end the program using the DOS service. So we have to write move AH, 4CH and int 21H and end the code segment and end of the main. So after typing the program, we have to go with MASM. MASM is the macro assembler file name .asm semicolon. So this will give the list of error. If there is no error, we have to move on to the next step. If not, if it is the error, then we have to go to the previous step, which is nothing but just we have to go back to the editor window, type, correct the error, then we have to come back to the next step. So now we have to type link. You're going to link the object file. So link the file name .obj semicolon. So once this is done, we have to move on to the next step, which is nothing but debug file name .exe. Executable file we are going to view. Which is nothing but the code view. Here we can able to see the instruction code for the mnemonics. So these are the mnemonics and these are the instruction code, and this is your code segment followed by the offset. And here we have to give u, which is nothing but unassembling. After typing u, we can able to go with the execution. So we have to write G for go. We have to give the starting address of the offset, which is nothing but 00, and the end address of the offset here is 0019. After typing this, we can able to see all the registers present in 8086. Say here the code segment, this is your code segment. Here the code segment address is 076B. We can able to see code segment is 076B and the data segment is 076A. After the execution, we have to go for display the result. So for that, we have to type D for display data segment colon 00. So what are the two numbers we have taken? The first number is 7F, the second number is 0E. This is the dividend and this is the divisor. So we have the quotient and this is the remainder. So we know for this example, the quotient is 09, the remainder is 01. And already we told the data segment address is 076A. We can able to verify this is your data segment and this is the offset. How to see the output? So in the program we have written in the place of quotient and remainder, we have written what? A result and the result plus 1. So we can able to see the result address is nothing but 002. The result plus 1 is 003. So in that particular location, we can able to see the output. So this is the quotient and this is the remainder. We'll move on to the next one, a 32 by 16-bit division. So in this program also, we have to go with a two numbers. Here we have taken a two number. What is the difference when compared to the previous program? In the previous program, we have defined as a byte, but in this program, we are going to define as a word. So we are going to perform a 32 by 16-bit division. So in case of 32 by 16-bit, we have to take dx with 00. So first we will see we have to go with the assembler directive dot model small. So we have many models here. We have huge, a tiny, a compact, a large. We know that, okay, for writing a simple program, the code segment size should be less than or equal to 64 KB and data segment should be less than or equal to 64 KB. So in case of large program, we can take the code segment is greater than or equal to 64 KB or data segment of greater than or equal to 64 KB. In that case, we have to write dot models large. After that, we have to initialize the data. We have num1, num2, define word. These are the two numbers we have taken for calculation 2244 and 00D6. Then we are getting the result. Here the result is what? A double word. So we have taken DW2, which is nothing but the two copy of a word is created in the location. The space is allocated in the location. So once this is done, we have to go over take the address assigned to DS, take the first number, move it to AX. We know DX we have to load it with 00, take the second number, move it to BX, and we have to use the mnemonics for unsigned division. And here the syntax is what? div bx. After that, we will be getting the result in AX and DX. The AX will have the quotient, the DX will have the remainder. Then we have to end the program. So we have to go with masm, the file name dot asm semicolon. Afterwards, we have to type link a file name dot obj a semicolon. So debug a file name dot exe. So this is what a code view executable file we are going to view. Then we have to go with U for unassembling. So we have to give the starting address and the ending address of this in 21H for the execution. So in the next step for we have to go with G is equal to the starting address and the end address of the int 21H, which is nothing but 001A. Afterwards, we can able to see all the registers. Then we can able to view the flag register content here. So now we have to perform, this is the number we have taken 2244. We know that when the data is stored in the location, first the LSB of the data will be going followed by MSB. So in 2244, the LSB is 44 and the MSB is 22. So here also the number we have taken in BX is 00D6. So the LSB of the data is D6, the MSB is 00. See, after this, okay, we will be getting the quotient and the remainder. For this calculation, we got the quotient as 2, the remainder as D4. So when it goes to the location, how it will happen? First LSB of the data will be moving, followed by the MSB. Thank you all.